just to get us started here, I model with base 10 blocks, and so this one here, I don't know if you can see it, but it is segmented into 100 little pieces, but we're going to call that our whole one. Okay, so that's going to be our 1, which is also the same as, if you're looking at a fraction, as 1 over 1, which is also, if you're talking about percent, it's all of it, it's 100%. Right, and if this is our 1, then we could say that this block here, can you see how there's actually 10 little pieces in there? But we're just looking at the 1 block by itself right now. There's actually 10 that fit in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we are talking about this in terms of this, it would be 1/10 of it. And we can write that as a decimal as 1/10, as a fraction as 1/10. Or as 10%, because there's 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, 100%. If we go back over here and we talk about this 100%, it's because each of these is worth 1%, 1, 2, 3, 1%, 2%, 3%, 4%, 5%, 6%, and you could count all the way up to 100%. Then if we look at this one here in terms of this block, then this would be 1%. Right? It's just 1 out of the 100, or we call it 1/100th, 1 out of the 100, or 1%. Now, I don't have a block for the thousandths, and the thousandths would mean that I need to cut this little one into 10, because I don't know if you've noticed, I took this big one, I cut it into 10, that's how I get that piece. Then I take this one, I cut it into 10, and I get this piece. So now I need to cut that into 10 to get that piece, and I don't actually have those blocks, but you could do this on graph paper. And or you could, use a little Play-Doh, or I don't know, cut some tiny strips of paper out, make sure that you cut a little square like this, and then just cut it into 10 little slices. And that would be 1,000 of those would fit in here, because there's 10 in every little square here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that's 100, 200, 300. And if you go all the way up, you're going to get 1,000 of those little pieces will fit in here. And the way we write that as a fraction is 1,000th, as a decimal 1,000th, as a fraction 1,000, and as a percent it's just 0.1%, because it's 1/10 of 1%. Now, if that's our 0.1%, we could use this block here, which I've actually taken one of these cut it in half, and that would mean that 5 of those fit in there, and that means that I would have 5/1000ths in this thing here. So 5/1000ths, and that's how I would write 5/1000ths with a decimal. 5/1000ths is a fraction, and as a percent, it's actually 0.5%, because it's half of a percent. It's a half a percent. It's half of this 1%. Can you see that? That's half of that. Okay. We could write that as 5/1000ths. We could also write it as 0.5 hundredths, because it is a half of a 100th. Okay, so that's just some of the setup for the blocks. Okay, so you were asking about 37.5 out of 100 and how that is the same as 3/8 and why. So 37.5 hundredths is the same as 10, 20, 30. 37.5, if you're counting hundredths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we're doing is counting these little green ones, but I'm using blocks that have 10 in them, 10 in them, 10 in them, so 30, and then 7, 37, and then half of one of those. So 30.75 hundredths. Okay, so how do we get the 3/8? What you have to do is you have to reshape. And when I talk about reshaping, it's the same as rewriting your symbols. So I'm going to reshape these blocks over here, and I'm going to reshape these blocks over here. And what I want to do is I want to have the same over distance on both of them. So I still want to have 37.5 here, and I still want to have 100 here, but they're going to look different. Okay, just like this looks different than that. And when I do, what I found out is that 12.5 goes into 37.5 3 times. So I'm going to put 12.5 here and 3 here. So because there's 12.5 three times. And I also found out that 12.5 goes into 100 8 times. Now I don't know if you notice here, but we've got rectangles here and both of them have the same over distance. And when we have the same over distance in a rectangle, it's the same as it's the same as 1. So 12.5 over 12.5 is the same as 1. Okay? We don't need to pay attention to a 1 in a fraction, because anything times 1 is just itself. Okay? So what we end up here is 12.5 times 3, which is still the same as 37.5. Can you see? 10, 20, 30, 32, 34, 36, 36.5, 37, 37.5. And then also we have 12.5 times 8 on the bottom. Okay, can you see that? There's 1 12.5, 2, 3, 4, 5, 6, 7, 8 12.5s. Okay, and because this here is a hidden 1, what we really can do is just actually, well, you can either write a 1 right through it, okay, or we just get rid of it and we're left with 3/8. Another way to do it is just put 12.5 on the top times 3/8 and 12.5 on the bottom times 3/8, and you can just cross it out like that because it's just a 1. What you're left with is 3/8. Okay, all you're doing really is finding a common factor that goes in here and in here, and that becomes your hidden 1. I call it no fun, get back to 1. And then what you're left with is your up distance or your down distance, if you want to look at it. I prefer to look at it as the up distance. You've got 3 here and 8 of your rectangles. So you got 3/8, okay? Because this is just a 1. And so this is where you get this from. 12.5 times 8, 12.5 times 3, there's your hidden 1. And you end up with 3/8. I mean, you could do it differently and do division. You could say 37.5 divided by 12. Well, that's 100 divided by 12, and that's 8. So if you wanted to write it slightly different, it could look like this. All right, so divided by 3, or sorry, divided by 12.5, not 12. Divided by 12.5 on the top and bottom, and you end up with 3/8. Okay, so that is how you come up with 3/8 from that. And you can put this on top of here if you wanted, and you can see that that's 37.5 out of 100, which is also the same as 37.5%, right? And also you could write that as your fraction, 37.5 out of 100. And if you wanted to write it as a decimal, well, you have 3/10. There's your decimal place. You have 3/10, 3 of these blue ones. And you've got 1, 2, 3, 4, 5, 6, 7 hundredths. And then you've got 1, 2, 3, 4, 5. Yeah, remember the little ones that I said you would cut this one into? You'd get 10 of them. Well, there's 5 in that half of one, and so there's 5 thousandths. So 37.5 out of 100, 37.5%, or 3/10, 7 hundredths, and 5 thousandths. So just a little side note, if we wanted to put these on top of here, right, can you see that this many is 3 out of the 8? Because this is what we're talking about, what we have. We actually don't have the whole 100 or the whole 8 of these 12.5s. We have 3 of the 8 12.5s. So we have 3 of these, which is where you get that fraction 3/8. So again, let's talk about 37.5%. So here's your whole one, and that would be 100%, right? But we don't have 100%. We have 37.5%. So we have 37.5. Can you see how that's, I'm going to actually put that down here. Can you see how that's 30, 10, 20, 30, 37.5 out of here? It's not the whole thing, it's 37.5%. We don't have the whole piece, we just have part of the piece, okay? And that's the same as 3/10, because remember, each one of these fits into here 10 times. So 3/10. And then if we're looking at the individual pieces in here, we have 7/100. And then this is those little tiny little ones that I was telling you about. And there's 5 in there, 5/1000. So now we've got that as a decimal, right? And again, it's the same as if you divide this by 100 and go back 2 spaces, right? Because again, there's your 100 hidden in there, 100, okay? So all you got to do is actually divide 37.5 by, or 37.5 by 100, and you'll end up with 0.375, okay? We could write that in terms of tenths, which would say that we've got 1, 2, 3, and 3/4, because I don't know if you can see that, but that 7 can be replaced by these. I'm just gonna, that 7 can be replaced by these. Can you see how that's still 7 right there? Or did I get too many in there? Or that 7.5, I should say, can be replaced by those. See, that's 7.5. But each tenth actually has 4 of those 2.5s, and see 2.5, 5, 7.5, right? So really what we have, if we're writing this in terms of tenths, I'm just going to move that for a minute, is we have 3 and 0.75 tenths, or 3, you could even write this as 3 and 3/4 tenths. Okay? And that's the same thing, right? 3.75, 3 and 3/4 tenths. Or we could write this in terms of hundredths, right? Let's take that back off. Okay. And we would have 10, 20, 30, 37 and a half hundredths, 37 and 1/2 hundredths. Or again, you could write it as 37 and 1/2 hundredths. Those are all equal. Okay. Now maybe we want to write it in terms of thousandths. I'm going to write that down here because I'm running out of room on the side there. So if we want to write it in terms of thousandths, again, we're talking about those tiny little pieces. And there's 1,000 of them in this big red one. But in here, there's 375 thousandths. There's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 100, 200, 300, 375 thousandths. So you can write this as all of these different fractions, and they're actually the same. I think it's important to know that different fractions mean the same thing. And again, if you take your calculator and you go 3.75 divided by 10, well, your decimal's going to go there, 0.375. 37.5 divided by 100, your decimal's going to go back 2 spaces, 0.375, same thing. And 0.75 is the same as 3/4. 1/2 is the same as 0.5, right? And then 375 divided by 1,000, your decimal is going to go back from here, 1, 2, 3, 0.375. Do you see how they're all the same? They look different, they sound different, have different names, right? And in this particular case, if I had, like with this, if I had, 375 of the little pieces like that, I could line them all up and it would be the same shape as this, but it would look different. And it would still be the same amount, right? And I could actually take, if I wanted to, for hundredths, I could take, 37 of these little ones, 37 and a half of those little ones, and line them up here. And you could see it would be the same size. But instead what I've done is I've used 3 of these and 3/4 of one of those. And it kind of models all of it. You just have to use your imagination a little bit. And or if you had the blocks, you could, get a bunch of these out and actually show how they're all equivalent. But I think you can see it. I'm hoping that you can see it. Okay, so again, looking at 375 over 100, or sorry, over 1,000, and trying to simplify that, really all we're looking for is a number that we can times another number by on top, and that same number that we can times another number by on the bottom, and still have 375 on top and 1000 on the bottom. And in this particular case, I mean, we could look at it as 37.5 and divide it by go 12.5 times 3 on the top and 12.5 times 8 on the bottom, and then you've got 3/8. But in here, you could actually look at this as 125 thousandths on the top times 3. And that will give us 375 thousandths. And then we could actually go 125 thousandths times 8 on the bottom, and that'll give us our 1,000 thousandths, right? And then this is our hidden 1, and we're left with 3/8. So again, just so many ways that you can come up with that 3/8. Just try stuff. It's really quite amazing when you start playing with this, all the different ways you can get to the same result. So you asked about 12.5% and how to change that to a decimal and how to then change that to a fraction. If you look at this, and this is our 100%, right? We've got 10, 12.5% or 12.5%, because you could call that 12.5%, right? You could write that as 12.5%, because we have 12 out of the whole 100 plus another half of 1 out of the whole 100. Okay, so we could say that's 12.5% or 12.5%. Okay, but we want to change that to a decimal. So if you look at this, can you see how we have 1/10? Because 10 of those would fit in there, so we have 1/10. And then we have 2/100ths, because that's 2 of these little green ones. 2 of those little green ones. 1, 2. So we have 2/100ths. And we have 5 of, remember I mentioned about cutting this into 10 little pieces? That's not a very good depiction of it. My felt pen's too thick. But you would, when you cut when you have your 100%, and you cut it into 10 pieces, you get one of these, which is a 1/10. Okay, so if we talk about this as our whole one, like our 1, then this would be 1/10 of it. This would be 1/100th of it, and those little lines that I talked about would be 1,000th of it. So 10 of those fit into this, 100 of these fit into this, and 1,000 of those fit into this. But because I don't have any of those little blocks, this is 5 of them. It represents 5 of them. Gotta squish them together. I can't draw them small enough to on the desk, but there's 5 thousandths in there. So when you turn this to a decimal, you have 1/10, 2/100ths, and 5 thousandths. Okay, another easy way to do that is just take that and divide it by 100, 12.5% out of 100. Right, if you divide it by 100, that goes back 2 places. Okay, and you end up with 0.125. That's a little trick that you can do, but really it's just basically you're dividing it by 100, because this sign here, this here, I don't know if you've noticed that, but that's really 100. Do you see? There's your 1, there's your 2 zeros, right? You're just dividing by 100. Okay, so then if we want to turn that into a fraction, right? Well, don't we have just 12.5 out of 100? So writing this as a fraction, we could say that we have 12.5, sorry, we have 12.5 of these, we have 12.5 of those, and those are hundredths, so we have 12.5 of those. We could also say that we have 1.25 of those, so we have 1 1/4. I can see how that's a quarter of that. We have 1 1/4 of those, and that would be tenths. Okay, and I don't know if you noticed, but if I divide by 100 here, I'm going to get my decimal back there. I divide by 10 here, I'm going to get my decimal back there. So I could also say that this is 125 of those teeny tiny little ones, of those thousandths. Can you imagine that there's 10 in each of here, 10 of those little lines that I was talking about? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 125 thousandths. So there's different ways to write this. A lot of people don't show that you can write this in here, but if you actually take that and you punch it into your calculator, which I have my handy dandy calculator here, and you go 12.5 divided by 100, it's the same as 0.125. I don't know if you can see that. And then if I go 1.25 divide by 10, it's the same as 0.125. If I go 125 and I divide it by 1,000, it's the same. Oh, I did that one wrong. 125 divided by 1,000, not 100, is 0.125. Okay, so these are all equal values. Now, one of the things that I teach kids, and it really, really helps, is that things can be same, but they can look different and they can sound different. They can have different names and yet still be the same. Okay, but this is, again, like I said, 125 of those tiny little pieces. This is one whole one of the tenths plus another quarter of that tenth. This one here is 12.5 of these tiny little ones, right? And it's the same as 1/10, 205 thousandths, which is the same as 12.5%, right? 12.5 out of the whole 100%, because this is your 100%, that's 12.5%. I'm not sure, I'm hoping that this actually makes some sense to you. I know I'm throwing a lot at you real quick. One other way we can look at 12.5% and turn that into a fraction is we could say that this is 12. Well, first we could change it into a bit of a more complicated fraction and just say it's 12.5 out of 100, because what we're talking about is this is our whole one, right? And there's 100 of these little pieces in there, 100 of those little pieces in there, and this is the same as 12 and a half of those little pieces, okay? But we could also look at that differently, because we do have halves here, right? So we could say that in each one of these hundredths that we have 2 halves. So 2 halves, 4 halves, 6 halves. This would end up being 20 halves, so that's the same as 20 halves plus 4 halves plus 1/2 of the 100 pieces, which means that we have 25 halves of the 100 pieces, 100th pieces, I should say. I'm getting tired. And we could multiply this all by 1, because if we multiply by 1, we don't change the value, but it helps us get rid of the denominator. And down here's another hidden one. There's always hidden ones. This is a hidden one, really, because 1 over 100 over 1 over 100 is 1, right? And what happens here is this cancels that out, right? Because it's 100 times 1 over 1 times 100, which is the same as 1. And we don't need the 1 on the bottom. And then 25 goes into there once. 25 goes into there 4 times, right? And then it's just 1 times 1 on the top, and it's 2 times 4 on the bottom, which is 1/8. So that's another way to get to 1/8 as well. Okay, so 12.5% means that we've got 12 and a half of the little hundredth pieces. Okay, so we've taken our 1 and we've split it into 100 pieces, and we've got 12 and a half of those pieces. That's what that means, 12.5% or 12.5%. You could also write that as 12.5%. Okay. If we wanted to change that into a fraction, all we need to do is really count the pieces, okay? So we have what am I thinking here, actually? Yeah, if we wanted to turn that into a fraction, we could just go 12.5 out of 100 pieces. Okay, and this is 12.5 out of 100 pieces. In order to simplify that, what we want to do is just reshape this and find out basically a number that we can times another number, one number that we can times a number on the top by and a number on the bottom by, and still have 12.5 on top and 100 on the bottom. And basically it's kind of like finding a common factor within it. Okay, now when we did the 37.5%, we found out that 12.5 goes into 100 evenly, right? It goes into it 8 times, right? So we're just reshaping here. This is still 100, just like this is here. If I could put that up there if I wanted, right? So I'm taking this 100 pieces here of my 1, and I'm reshaping it so that's 12.5 across, and then it's going to be 8 up. And I'm just taking this and reshaping it this way, right? And so it's 12.5 across, and it's 1 up. So right away I can see that my fraction is going to be 1/8, because it's really one of those 8 pieces, one of those 8 12.5 pieces. Can you see that? It's one of those 8 pieces. This 12.5 is like a hidden 1. So if we were looking at it with the symbols, I'll just put this up here, we can say it's, I'll just carry that down there, 12.5 times 1 on top, and it's 12, let's make that smaller, 12.5 times 8 on the bottom, which is really the same as saying that I've got 1, because isn't 12.5 over 12.5 just 1, times 1 over 8, which is the same as just 1/8, right? Now, if you want to turn that into a decimal, and I'm going to move these now because I think we're kind of done with that. If you want to turn that into a decimal, that just says that I've got 1, and I'm dividing by 8, right? And I can see that that's going to go into there. What am I thinking here? 1 time. There's going to be 2 left over, right? And that's going to go into there 2 times. Right? And there's going to be 4 left over, and that's going to go into there 5 times. There's going to be nothing left over. So I've got 0.125 is my decimal. But that's not exactly the way I would do it. What I would do is I would say, okay, well, I've got 12.5 here, right? Let's just do it this way. Let's look at the pieces. Let's just count the pieces. What do I have? Well, I've got 1/10, right? And don't I write 1/10 like that? And I've got 1/200, and then I've got 5 thousandths, because remember I told you that that little one is worth 5 of those tiny, tiny pieces. If I were to split one of these up into 10, right? If I split that up into 10 and I took half of it, I would have 5 of those tiny little pieces. So I have 1/10, I have 200ths, and I have 5 thousandths. And so that's how I would do my fraction, because it makes more sense. But you can, or sorry, your decimal, you can do your decimal this just by doing division. But it's better when you're showing the kids that they can understand what that means. Why is it 1.25? It's because I've got 1/10, 200ths, and 5 thousandths. Okay. I could write this fraction. I think I may have done this in the other video, but I could write it as 1.25. This fraction here over 10. Could also write it as 125 over 1,000, right? Because there's my decimal place divided by 1,000. I'm going to have 0.125. There's my decimal place divided by 10. I'm going to have 0.125. There's lots of different ways to write this. You could also write this as 1 1/4 over 10, because isn't that the same? You could also write this as if you look at this, actually, you could say that I have that 125 goes into there once, and 125 goes into there 8, because isn't that the same as 125 times 1? And isn't that the same as 125 times 8? Right? There's another way to get rid of your 1, and you're left with 1/8. All right, so many different ways to approach this. I think just start off really simple. The ones that you've got there might be a little bit tough, but you know, start off simple and then get bigger. So learn the concept first and use small numbers, and then once the concept is understood, then you can get bigger and use, you know, more complicated numbers like things like 16 2/3%, right? So just start off small and then get bigger. So 16 2/3% means that you have 16 2/3 of the 100 pieces, and there's 100 in here. And we've got 16 2/3 of those small pieces. Do you remember we were talking about that size there? We've got 16 2/3 of those pieces. Okay. If you actually look at this, we could turn this into all into thirds. Okay. For every one of these, there's 3/3. So there's 3/3, 6/3, 9/3 of. That's 3/3 of 100th, and 6/3 of 100th, 9/3 of 100th, which means that we really have 30 thirds here, plus 18 thirds here, plus 2/3 here of 100th. So we have 30 thirds of 100th, right? This is 30 thirds of 100th. This is 18 thirds of 100th. And this is 2/3 of 100th. If you add all that together, you end up with 50 thirds of 100th. Okay? And if you simplify it the way I'm pretty sure you've been taught, you know, you can basically multiply by 1 over here. And we use a 1 that works for us so that we can get rid of the bottom here. You see 100th over 100th is the same as 1, but that allows us to cancel out this, right? And then 50 goes into 50 one time and into there 2 times, and then we go 1 times 1 is 1, and 3 times 2 is 6, and so that's how you get your 1/6. Okay, and if you actually take your calculator, and or if you do division, which is 1 divided by 6, right? You're going to find out that this goes 1, if you put another 1 there and put a 4 there, you'll see that that goes 1.6, and it keeps going. I'm just doing short division. I'm not sure if you've seen that before or not, but it keeps going. No matter what, you're going to have another 6 there. Okay, so this repeats. Okay, so 1/6 is the same also as 0.166. 6. It can keep going. A simpler way to write it is just 0.16 repeating. Okay, so you can go from your percent to your fraction, and then all you do is do your division, and you end up with this. What this means, though, is 0.166 repeating, is that, and let's just do this. Let's just erase that for a second. It means that we've got 1/10, and then we've got 6/100ths. And then we're going to add on 6 of the thousandths. And then we'll add on, and I had a little piece here. I think I got something on there. 6 of the 10,000ths. And then we would do 6 of the 100,000ths, 6 of the millionths, and so on. We keep adding on 6 more smaller pieces. Each piece that goes this way gets each of the 6 pieces that we add on this way are smaller and smaller and smaller. So this gets cut into 10 pieces. This gets cut into 10 pieces, and we take 6 of them. Then this little one here gets cut into 10 pieces, and we take 6 of them. And then the thousandths, those little tiny ones we talked about before, get cut into 10 pieces, and we take 6 of them and add it on, and then we take that and cut it into 10 pieces and add 6 of them, and then get smaller, and you barely can see them, but you're going to continually add on 6 more smaller pieces. And that's what that means, that this is repeating, because you're constantly adding on smaller pieces. Okay, so that's this is actually a pretty easy way to find out that it's 1/6 or 0.16 repeating. It looks complicated, but it's not so hard. So right here we have 37.5%. and we can rewrite that as 37.5%. That's the same thing. And all we need to do to change this into a decimal is take the percent sign. Do you see that there's a 1 and 2 zeros there? Take our percent sign, put it on the bottom. There's your 1 and 2 zeros. Now it tells you that you got 37.5 and you're dividing by 100. And when you do that, your decimal goes back 2 places to the left and you end up with 0.375. Here we've got 12.5%. Or sorry, let me rephrase that. We have 12.5%, which is the same as 12.5%. Do you see our 100 right there? I'm going to take that, we're going to rearrange it and put it on the bottom. And that tells us we're going to divide the top by 100, which means the decimal is going to go back 2 places to the left, which is going to be 0.125. Okay, and then we have over here, we've got 16 2/3%, which is the same as 16.6 repeating percent. There's our 100, 1 and 2 zeros. We're going to take it, we're going to rearrange it and put it on the bottom. And that tells us that we're going to move that decimal place 2 places to the left, which means we're going to have 0.16 repeating. I mean, you could write it if you wanted. You could leave that 6 in there. It could be 0.166 repeating, because it just, you're going to have 6s no matter what. You could stop anywhere you want. You can stop way out here or stop back close to the 0.1. But the key to this is taking that 100 there, reshaping it and putting it on the bottom. And it's a simple little trick, and kids can remember that because they can